So we're going to move forward and talk a little bit about polar and rectangular conversions, and we've done this a little bit already with our vector conversations. If you look at the diagram over on the left, we know a point in space can be described by not only its x and its y coordinates, which we're used to, but some radius followed by an angular measure to rotate to in order to get to that point. Now we know that we create this right triangle, and with that we can do some conversions, if you will, from a polar coordinate to a rectangular coordinate. So if we're given the r value and the theta value, we have a sine and cosine relationship saying the sine is the opposite over the hypotenuse, the opposite being the y value, the hypotenuse being r. Multiplying r to both sides, we get r sine theta, which is equivalent to the y value. And likewise over here, we get r cosine theta, equivalent to the x value. So if we wanted to go from polar to rectangular, all we have to do is use this idea of r cosine theta and r sine theta to get our x and y values. Likewise, if we're given x's and y's, and we want to go to r's and thetas, we know we have a right triangle, and x squared plus y squared is r squared. So r is equal to the square root of x squared plus y squared. That's just a Pythagorean relationship. And then we know we have a relationship between theta and the x and y values. The y over x is equal to the tangent ratio. Take the arctan, and that gives us our angle theta. So this gets us from rectangular to polar. You need to note, though, what quadrant you're in order to use this tangent ratio, because you know due to principal values that our values are only going to be output between 90 and negative 90 degrees as defined by the principal values. So let's do some applications of this. If we want to convert the 3 and 2 110 degrees to a rectangular coordinate, we need to have an idea of where 3 and 210 are. That's somewhere in the third quadrant, so I should be getting a negative x and a negative y as my answer. And if we want to go from rectangular, or from polar, excuse me, to rectangular, we just take whatever that radius was, multiply it by cosine of the angle, 210 in this case. That gives us our x value. And take that radius and multiply it by the sine of whatever that angle is. And now it just turns into a calculator problem. The value of 3 cosine 210 is, let's go to 100, it's negative 2.6. And 3 sine of 210 is negative 1.5. So this gets us a negative and a negative, and appears to check out. Now if we want to take and convert negative 2 and negative pi over 4, that's roughly down here in the fourth quadrant, so we should be getting some positive negative value for our x and y. And it's the same basic calculation, except now we're in radians. So we're going to take negative 2, multiply that by the cosine of negative pi over 4, and negative 2 multiplied by the sine of negative pi over 4. We know these are unit circle points, so that's negative 2, and the cosine is positive root 2 over 2, and this is negative 2, and we get a negative root 2 over 2 for the sine of pi over 4 negative. 2's are going to reduce in both cases, thus getting us, for our cosine value, a negative root 2, and for our sine value, a positive root 2. Now that kind of contradicts our picture, and you'll notice why, because what I didn't account for was that I have a negative radius measure. So having a negative radius measure means taking and adding 180 degrees to that. So therefore, this is where our negative 2 and negative pi over 4 should end up going. So good learning tool in this case. And that would make sense because I have a negative and positive, and that's what I should end up with in the second quadrant. Moving forward. I want to go to polar coordinates now. So we're taking an x and a y and converting it to an r and a theta. We know that we have the Pythagorean relationship of 2 squared plus negative 4 squared, all square rooted, will give us our r value. And the arctan of the y over the x should give us our theta value. Looking at the point we're given, positive 2, negative 4, we're somewhere down in the fourth quadrant, so we should expect positive r value out and some negative theta value. All right, and let's go ahead and do that. We get the square root of, let's see, 16 and square root of 20, so that's 2 root 5. We can leave that like that, and then we just take the arctan of negative 2, which gives us roughly negative 63.43 degrees. And that'll do. To our next example, this is a little bit different. We want to write an equation of r equals 3 in rectangular form. So this r equals 3 here, this is in polar. So now we're talking about converting polar equations to rectangular equations. Easiest way to do this is the following. We know that r is equal to the square root of x squared plus y squared. And if we're going to put something in rectangular form, we want it in terms of x and y. So I'm just going to make that substitution. I'm going to say that the square root of x squared plus y squared is equal to 3. Thus we have x squared plus y squared equals 9. And we know that is the equation, if you remember, of a circle whose center is 0, 0. And that's exactly what we would get with r equals 3, because we go out 3. Everywhere there's a radius of 3, we have a circle, and there we have it. So x squared plus y squared equals 9 is our converted equation. This one looks a little bit tougher. All right, and what we're going to do in this case, again, we want to go to our x's and y's given our r's and our theta values. So let's clean this up a little bit first. We know that this is equivalent to 2r minus 3r sine theta is equal to 6. That would be my first step. Get everything on one line. Now, we've already stated that r is equivalent to the square root of x squared plus y squared. So I'm going to make that substitution here. Now, I could do the same thing in this case, but I'm left with this sine theta, which is kind of a weird deal. But I know I have an equivalent for r sine theta. We know that y is equal to r sine theta. So I'm going to go ahead and make that substitution. This gives me then 3y is equal to 6. So now it's just a case of cleaning things up. I'm going to bring the 3y to the other side, leaving me 2 times the root of x squared plus y squared equals 3y plus 6. I'm going to take and square both sides to get rid of this square root, because typically they don't like square roots as your final answers. Give us 4 times x squared plus y squared. This term's going to have to be FOILed. So that's 9y squared. 18 and 18 is 36y plus 36. Then I set aside equal to 0 because we want this in standard form. And that's typically with all the x squareds and y squareds on one side of the equation. So I have 4x squared. This is 4y squared minus 9y squared, which is negative 5y squared. Bring the 36y over, that's 36y, and I bring the 36 over. And this is my rectangular equation. And in our next chapter, we're going to talk about what kind of shape that is. You should probably know what that is already, but we'll get there. So let's keep moving. Now we're going to go the other way, and we're going to write the equation in a polar form. So if we want to do that, we're going to make our substitutions for x's and y's that we've done in the past. And we know that our cosine theta is equal to x, and our sine theta is equal to y. So I'm going to make those substitutions in for x and y where I see them in this equation. Doing this, I get r cosine theta for x, but I have to square that. And I get r sine theta, let's put a plus in between there, for y minus 1, that's got to be squared, is going to be equal to 1. Again, we're going to have to simplify this a little bit, so multiply all this out. I get r squared cosine squared theta plus this term is going to have to be FOILed, r squared sine squared theta minus 2r sine theta plus 1 is going to equal 1. So you'll notice if I bring the 1 over to the other side and notice that I have an r squared in common here, I have r squared times cosine squared theta plus sine squared theta minus 2r sine theta is equal to 0. Sine squared plus cosine squared we know is 1, so I'm left with r squared minus 2r sine theta is equal to 0. I can clean that up a little bit by taking and bringing the r squared, isolating that, bring the 2r over to the other side, and then dividing out an r, giving me r is equal to 2 sine of theta. So that's as simplified as we get. And that ought to do it for the day. Remember, you've got basically 4 equivalents you've got to know about.